Our solar system is a vast and wondrous place. It's filled with planets, asteroids, and comets. But some of the most fascinating objects are the moons. Saturn, the ringed giant, boasts a particularly impressive entourage. With over 80 moons discovered, Saturn's system is like a miniature solar system itself. Some are gigantic, like Titan, with its own atmosphere and methane lakes. And among these stories we find the intriguing case of Polydeuces, a moon so small it was once hidden in plain sight. By studying Polydeuces, we gain a deeper understanding not only of Saturn's system, but of the intricate processes that gave birth to the planets and moons we see today. Discovering a moon is no easy feat. It requires powerful telescopes and meticulous observations. Astronomers spend countless hours peering into the depths of space, searching for the faintest glimmer of light. For centuries, only a handful of Saturn's moons were known. But with the advent of modern telescopes and space exploration, the number began to grow. Spacecraft like Voyager and Cassini revolutionized our understanding of Saturn's system. In 2004, a team of astronomers using the powerful telescopes at the Mauna Kea observatories in Hawaii made an exciting discovery. They spotted a tiny point of light moving near Saturn, later named Polydeuces, adding yet another piece to the puzzle of Saturn's complex and dynamic moon system. Polydeuces is a small moon, estimated to be only about 3.5 kilometers in diameter. That's smaller than many cities here on Earth, but despite its diminutive size, Polydeuces plays a fascinating role in Saturn's moon system. It shares its orbit with another larger moon named Dione. This type of orbital arrangement is known as a Trojan configuration. The discovery of Polydeuces in this Trojan configuration with Dione provided further evidence of the complex gravitational interactions that govern the motions of celestial bodies. In the vast expanse of our solar system, there are undoubtedly countless more secrets waiting to be uncovered. The discovery of Polydeuces was not a mere stroke of luck. It was a testament to the power of human ingenuity and our relentless pursuit of knowledge. Imagine searching for a firefly against the backdrop of a fireworks display that's akin to finding a tiny moon like Polydeuces amidst the grandeur of Saturn's rings and its retinue of brighter moons. It took the advent of advanced telescopes and imaging techniques to finally pierce through the veil and reveal this tiny dancer in the cosmic ballet. It required meticulous observations, comparing images taken at different times to discern its subtle movement against the background stars. The team of astronomers who eventually discovered Polydeuces were not specifically looking for new moons. They were engaged in a broader survey of Saturn's system, hoping to refine our understanding of its known moons and their interactions. The universe often reveals its secrets in whispers, not shouts. Its faint signal, a mere whisper of light, could have easily been dismissed as noise or a flaw in the data. But the astronomers persisted, carefully analyzing their observations and running simulations to rule out other possibilities. By studying the subtle gravitational perturbations Polydeuces induced on its neighboring moons, astronomers could infer its presence and estimate its mass. It was a triumph of precision and a testament to the power of indirect observation. The term Trojan might evoke images of ancient Greek mythology and epic battles. In astronomy, however, it takes on a different meaning, albeit one equally captivating. A Trojan moon is a celestial body that shares the same orbit as a larger moon, occupying a stable gravitational sweet spot known as a Lagrangian point. Polydeuces is not alone in its Trojan dance. It shares its orbit with Dione, a significantly larger moon of Saturn. This discovery of Polydeuces as a Trojan moon added another layer of intrigue to Saturn's already complex moon system. Gravity is the invisible maestro orchestrating the cosmic ballet of our solar system. It is the force that binds planets to stars, moons to planets, and even galaxies together in vast clusters. In the case of Polydeuces, gravity plays a particularly fascinating role, locking it in a delicate dance with Dione and Saturn. Imagine a celestial tug-of-war. Saturn's immense gravity pulls on Polydeuces, trying to draw it closer, but Dione, though smaller than Saturn, also exerts its own gravitational influence. At the Lagrangian points, these gravitational forces are perfectly balanced, creating a sort of gravitational sweet spot where Polydeuces can reside in relative stability. Polydeuces is a small world, even by moon standards. Imagine a rocky, icy sphere barely scratching the surface of a vast cosmic ocean. Its diameter, a mere 3.5 kilometers, could easily fit within the boundaries of a large city here on Earth. Standing on the surface of Polydeuces, if such a thing were possible, would be a humbling experience. The horizon would curve away quickly, a stark reminder of the moon's diminutive size. The sun, a distant pinprick of light, would cast long, eerie shadows across the cratered landscape. Saturn itself, a majestic giant, would dominate the sky, its rings a shimmering arc of icy particles. By studying its surface features, its composition, and its interactions with other celestial bodies, scientists hope to piece together the story of its formation and its place in the grand tapestry of the solar system. Even from a distance of millions of kilometers, astronomers can glean clues about Polydeuces' composition by analyzing the faint light it reflects. This light, having traveled across the vast gulf of space, carries with it the spectral fingerprints of the elements and compounds present on the moon's surface. These spectral analyses suggest that Polydeuces is primarily composed of water ice, much like many of Saturn's smaller moons. This ice is not pristine, however. It's likely mixed with darker materials, possibly carbon-rich compounds or rocky debris left over from the early solar system. Like an ancient warrior bearing the marks of countless battles, Polydeuces' surface is pockmarked with craters, evidence of a long and tumultuous history. These craters, ranging in size from small pits to larger depressions, were formed by impacts from asteroids, comets, and other space debris. Each impact would have sent shockwaves rippling through the moon's icy crust, creating new craters and fracturing the surrounding terrain. Over billions of years, these impacts have sculpted Polydeuces into the world we see today, a testament to the relentless bombardment that characterizes our solar system. The distribution and size of these craters can tell scientists a great deal about the history of the Saturnian system. Polydeuces, despite its small size and seemingly insignificant role in the grand scheme of the solar system, holds valuable clues to understanding the processes that shaped our cosmic neighborhood billions of years ago. By studying its composition, its surface features, and its interactions with other celestial bodies, scientists hope to piece together the story of its formation and its place in the grand tapestry of the solar system. One prevailing theory suggests that Polydeuces, along with many of Saturn's smaller moons, might be remnants of a larger moon that was shattered by a catastrophic impact early in the solar system's history. The debris from this ancient collision, according to this theory, eventually coalesced under the influence of gravity to form the moons we see today. Another possibility is that Polydeuces formed independently in the protoplanetary disk of gas and dust that surrounded the young sun. Determining which of these scenarios is more likely will require further observations and analysis. Polydeuces, despite its diminutive size, plays a crucial role in the intricate gravitational ballet of the Saturnian system. Imagine a celestial tightrope walker, carefully balancing the gravitational pull of two massive bodies. Saturn, the ringed giant, and Dione, its larger lunar companion. That's Polydeuces, perpetually suspended in a gravitational sweet spot known as a Lagrangian point. At these Lagrangian points, The gravitational forces exerted by Saturn and Dione precisely counterbalance each other, creating a zone of relative stability where a smaller object like Polydeuces can reside. It's like finding a calm spot in the middle of a raging river where the currents neutralize each other. But this stability is not absolute. It's a delicate dance, constantly influenced by the subtle gravitational nudges of other moons in the Saturnian system and even the distant Sun. Polydeuces shares its orbital path with Dione, tracing a celestial waltz around Saturn in a synchronized dance of gravity. This type of orbital arrangement, known as a Trojan configuration, is a testament to the intricate ways in which gravity can sculpt the architecture of planetary systems. Imagine two race cars speeding around a track, one always maintaining a fixed distance ahead of the other. That's essentially what Polydeuces and Dione are doing, locked in a gravitational embrace as they whirl around Saturn. They are cosmic dance partners, their movements intertwined by the invisible hand of gravity. This shared orbit is not a mere coincidence. It's a consequence of the intricate interplay of gravitational forces between Saturn, Dione, and Polydeuces. The Saturnian system, with its myriad moons and intricate ring structures, is a celestial billiards table on a grand scale. Collisions between moons, impacts from asteroids and comets, and the relentless pull of Saturn's gravity have shaped this dynamic system. Polydeuces, despite its small size, is not immune to these cosmic collisions. Its surface is pockmarked with craters, evidence of a long history of impacts. Each crater tells a story, a testament to the forces that have shaped this tiny world. These impacts are not merely destructive. They play a crucial role in the evolution of planetary systems. Collisions can alter orbits, redistribute material, and trigger new moon formation. Studying craters on Polydeuces and other moons provides clues about the history of bombardment. Analyzing these craters, astronomers gain insights into the impactor population and the role of impacts in shaping the system today. Saturn's rings, a breathtaking spectacle of icy particles, are a dynamic and ever-changing system, sculpted by the gravitational influence of Saturn's moons. Shepherd moons play a crucial role, maintaining the structure of Saturn's rings. They confine the rings within well-defined orbits, preventing them from spreading out into space. Polydeuces, though small, exerts a subtle influence. These interactions create waves and ripples, much like a boat creates wakes in water. Studying Saturn's rings offers insights into gravitational influences. These observations refine our models of ring dynamics, understanding the balance of forces maintaining these structures. Exploring the outer reaches of our solar system is a challenging endeavor. It requires sophisticated spacecraft and patient scientists willing to wait years for data from these distant envoys. Polydeuces has been observed by several spacecraft in the Saturnian system. These encounters have provided valuable glimpses into this enigmatic moon. Voyager captured the first images of Polydeuces during their flybys of Saturn. These images revealed little detail about the moon's surface or composition. Cassini, arriving in 2004, provided more detailed observations of Polydeuces. Cassini spent over a decade orbiting Saturn, providing unprecedented data about the planet and its moons. Cassini's encounters with Polydeuces were often brief, mere flybys as the spacecraft zipped through the Saturnian system on its way to other targets. Yet, these fleeting glimpses, captured by Cassini's suite of instruments, provided valuable data points that have helped scientists piece together a more complete picture of this tiny moon. Cassini's cameras captured images of Polydeuces from various angles and under different lighting conditions, revealing its irregular shape, its heavily cratered surface, and subtle variations in its surface brightness. These images, though lacking the resolution to discern fine details, provided important clues about the moon's geological history and its interactions with space debris. In addition to imaging, Cassini also made spectroscopic observations of Polydeuces, analyzing the faint light reflected from its surface to determine its composition. These observations confirmed that Polydeuces is primarily composed of water ice, similar to many of Saturn's smaller moons. While Cassini's mission ended in 2017 with a dramatic plunge into Saturn's atmosphere, the data it collected continues to fuel scientific discoveries. Astronomers are still poring over the vast trove of images, spectra, and other measurements, uncovering new insights into the Saturnian system and its enigmatic moons, including Polydeuces. Cassini's observations of Polydeuces, though limited, have helped refine our understanding of its orbit, its size, and its surface composition. These data points, combined with theoretical models, provide a foundation for future studies of this tiny moon. The legacy of Cassini extends beyond the data itself. The mission has inspired a new generation of scientists and engineers who are eager to continue the exploration of our cosmic neighborhood and to unravel the mysteries of worlds like Polydeuces. Despite the valuable insights gained from past missions, Polydeuces remains a largely unexplored world. Its small size, its faintness, and its distance from Earth make it a challenging target for observation and study. Yet, the quest for deeper knowledge continues. Future missions to the Saturnian system, equipped with even more advanced instruments, could provide the high-resolution images, detailed spectroscopic data, and perhaps even in situ measurements needed to unlock the secrets of Polydeuces. Imagine a dedicated mission to Polydeuces, a spacecraft orbiting this tiny moon, mapping its surface in exquisite detail, analyzing its composition, and probing its subsurface structure. Such a mission, though technologically challenging, would be a scientific bonanza, potentially revealing clues about the formation of the Saturnian system, the history of water ice in the outer solar system, and perhaps even the potential for life beyond Earth. In the grand scheme of the cosmos, Polydeuces is but a tiny speck, a minuscule world orbiting a giant planet in a galaxy teeming with billions of stars. Yet, this seemingly insignificant moon holds profound lessons for anyone willing to listen to its silent whispers across the vast gulf of space. Polydeuces reminds us that size is not a measure of significance. Even the smallest celestial bodies can harbor secrets that unlock mysteries about the formation of our solar system and the intricate dance of gravity that governs the cosmos. Its very existence, locked in a delicate gravitational embrace with Dione and Saturn, speaks to the elegance and complexity of the laws of physics that govern the universe. By studying Polydeuces, we gain a deeper appreciation for the interconnectedness of everything in the cosmos, from the smallest particles to the largest galaxies. Polydeuces is not an isolated world, orbiting Saturn in silent solitude. It is part of a complex and dynamic system, constantly interacting with its larger sibling, Dione, and influenced by the gravitational pull of Saturn and its countless other moons. Its orbit, shaped by the gravitational interplay of these celestial bodies, reflects the delicate balance of forces that maintains the stability of the entire Saturnian system. Even the slightest perturbation in Polydeuces' orbit could have ripple effects throughout the system, altering the orbits of other moons and potentially even affecting the structure of Saturn's rings. This interconnectedness extends beyond the Saturnian system. The materials that make up Polydeuces, the ice, the rock, the traces of organic molecules, were all forged in the heart of a dying star billions of years ago. The very atoms that constitute this tiny moon were once part of something much larger, something that existed long before our solar system was even a whisper in the cosmic void. Our exploration of Polydeuces is far from over. Each new observation, each new analysis, Each new mission to the Saturnian system brings us closer to understanding this enigmatic world and its place in the grand tapestry of the cosmos. Future missions, equipped with even more advanced instruments, may one day reveal the presence of a subsurface ocean on Polydeuces, a hidden reservoir of liquid water that could harbor the potential for life. Imagine the discoveries that await us, the possibility of finding evidence of life beyond Earth, however simple, in the most unexpected of places. The study of Polydeuces is a testament to the power of human curiosity, our innate desire to explore the unknown, to push the boundaries of our knowledge, and to unravel the mysteries of the universe we inhabit. It is a journey that will likely continue for generations to come, a never-ending quest to understand our place in the cosmos and to unravel the secrets that the universe holds close to its heart.